Hello, we'll be discussing about AWS Certified Solution Architect Associate Exam Question Papers. I am Sundus Hussain. So let's get started. So the first question is, a solution architect wants to design a solution to save the cost for Amazon EC2 instance that do not need to run during a 2-week company shutdown. The application running on the EC2 instance's memory that must be present when the instances resume operations. So the question is quite clear that the company want to shut down the instances for 2 week, and in that 2 week period how they're going to manage the state of the instance, whether they want to stop the instance, whether they want to terminate the instance, or whether they want to do something else. So in this case we can do is the hibernation. So we can hibernate the instances. So run the application on EC2 instances enabled for hibernation. Hibernate the instances before the 2-week shutdown. Why we can hibernate the instance? Because once we are hibernating the instance, it will become very cost effective and we don't need to pay for that period of time. Now these features can be useful for certain application workloads, as hibernation stops the EC2 instance and saves the content of the instance RAM memory to the root volume. We will be saving the RAM memory. The hibernation feature is also available for Amazon EC2 on demand and reserve instances. So basically it is only available for two types of instances. This is not available for other instances like spot instances and other instances. Now what are the benefits of hibernating over stopping? Because we can stop also, but we have to choose the hibernation option. So the memory state is preserved first. Second, since the memory state is preserved and loaded again when the instance start, this reduces the boot time of the instance. Third, the long running process can continue without interruption. We don't need to interrupt it in between. The process will remain continuous. A great benefit if you want to maintain the in-memory caching layer or have some services that take a great amount of time to fully initialized. So we can hibernate the instances because of all these benefits. So let's dump and see what's our next question is. So next question is, a media company is designing a new application for graphic rendering. The application requires up to 400 GB of storage for temporary data that is discarded after the frames are rendered. The application requires approximately 40,000 random input and IOPS to perform the rendering. So what is the most cost effective storage option for this rendering application? So in this we can see there are 2-3 keywords we can search. Like supposedly they are asking about 400 GB of temporary data, and the data will be discarded after the frames are rendered, and there is approximately requires 40,000 random IOFs to perform rendering also, and it should be very cost effective. So we know that there are different level of storage, or the different type of storage system. So we have to select one of the storage system and let's see what it is. So the best option for it is a storage optimized Amazon EC2 instance with instance storage. So the option which is storage optimized instances, they're basically designed for high sequential read and write access to very large data sets on local storage. These instances are optimized to provide application with tens of thousands of low latency random IOPS. The instance store has no additional cost. So I'm going to explain it in details. So these are the notes which I have created. So we'll talk about the storage optimized instances, which is one of the Elastic Compute Cloud storage system instance. So there are basically 3 type of series in storage optimized instances. I series, D series and H series. The H series has the highest capacity and the lowest capacity. I series has the lowest capacity. And here we can see the storage optimized instances are designed for workloads that require high sequential read and write access. As mentioned in the question, that storage should be only for the temporary purpose, like it will be discarded afterwards. Only that is only for the read and write purpose. So whenever you'll see sequential read and write access, we can understand that this is storage optimized instance. So they are optimized to deliver tens of thousands of low latency random input and output operations per seconds. So what does this mean? This means that supposedly if we have any music application, or take an example of YouTube. So in YouTube, what is happening, that a lot of footfall, like a lot of people are accessing the data, like watching the videos, and a lot many people are uploading simultaneously. So there are tens and thousands of low latency. So whenever there is a term of low latency, we just have to visualize this in our mind. It should be storage optimized instance. So this is further divided into three types: D2 instances, H1 instances, I3 and I3N instances. The latest one is I3N instances, and we can see that in the D2 instances, they are well suited for massive parallel processing. It is suited for data warehouses. It is used suited for map and reduce Hadoop, distributed computing, log or data processing application. And virtual CPU is 4 to 36 present in this. And likewise you can see in H1 instances the virtual CPU is 8 to 64. So it is more than D2 instances, and likewise it is the highest in I3 instances. It is 2 to 96, like virtual CPU is 2 to 96. Likewise the RAM is 30.5 to 244 GB here. In H1 it is 32 to 256 GB in the H1, and likewise in I3 it is 16 to 768 GB. So it has the maximum capacity. Now the storage type in this is SSD, storage type in this is HDD. So networking performance is 25 gigabyte per second to 100 gigabyte per second. So you just have to remember the storage capacity. And even supposedly here you can see that family features up to 16 terabyte of HDD based local storage. So you can see that you have to remember this 16 terabyte. If it is mentioned in the question or somewhere in the interview that which instance type supports 16 terabyte of HDD based local storage, so you have to mention H1 instances. And likewise here you can see the I3 one, it supports relational database, NoSQL database, distributed file system and data warehousing. And the number of virtual CPU are the maximum. Even the RAM size is maximum, and here it is the minimum. So likewise you can see the difference. Now let's take the second question, the other question, the third one. A company has an application that runs on a large general purpose Amazon EC2 instance type that is part of an EC2 autoscaling group. The company wants to reduce future costs associated with this application. After the company reviews metric and logs in Amazon CloudWatch, the company notices that this application runs randomly a couple of times a day to retrieve and manage data. According to CloudWatch, the maximum runtime for each request is 10 minutes. So the memory is 4 GB and the instance are always in the running state. So you have to mention 2-3 keywords from this, like 10 minutes, and the memory usage is 4 GB. So which type of instance you will be using in this? or what exactly, or what features you will be using so that it becomes cost effective and it becomes easy to use. So to reduce the cost associated with running this application, the company can consider moving from a general purpose Amazon EC2 instance to more cost effective solution. And we know the most cost effective solution is AWS Lambda and Amazon EC2 Spot instances, because we know that AWS Lambda is serverless feature, and given that application runs and the maximum runtime for each request is 10 minutes, AWS Lambda can be cost effective option. Now AWS Lambda allows you to run code without provisioning or managing servers. You only pay for the compute time you consume. Now what are the steps involved with the migration? So we can break down into application logic. Like, ensure that the application logic can run in stateless short-lived functions. Then we have to create Lambda functions. So we have to develop Lambda functions to handle each part of the application logic, and we have to make sure that the time must not exceed 15 minutes, because in the question it is mentioned that the runtime should be 10 minutes. Like since the maximum runtime is 10 minutes, so we have to see in Lambda it is acceptable. Now the memory allocation also in Lambda, we know that it is in between 128 MB to 10 GB. So in the question it is written 4 GB, so it is also acceptable. Now we have to trigger the Lambda function. So for that you have to use Amazon CloudWatch events or Amazon Event Bridge to trigger the Lambda function based on the schedule or the events that currently trigger the EC2 instances. And for the data management, you can use the Amazon S3 database, DynamoDB, or other AWS services for data storage and retrieval, because Lambda function is here it is stateless. Now Lambda is a fully managed service that would automatically scale when necessary and would be highly available. A solution that deploys the application as a Lambda function reduce cost the most. Now the next question is, a company asks a solution architect to implement a pilot disaster recovery strategy for an existing on-premises application. The application is self-contained and does not need to access any database. So which solution will implement a pilot like DR strategy? So we have to see. So before answering it, let me tell you that what exactly DR strategies are. So before understanding that, we should know that what exactly is RPO and RTO. RPO is recovery point objective, RTO is recovery time objective. So in a simple word, I can say RPO is the age of file that have to be discovered after a system failure or disaster. Okay, like it is discovered only after there is a failure of the system, and it is always expressed backward in time. So in the picture you can see that this is backup window recovery. Like we should retain, or you can say you can backup in this 1 hour period of time, and that if you will be if everything will be recovered in that RPO, like in that 1 hour, then it will be very cost effective. And if it is not going to take more than 1 hour, it will be a, you can say, the cost effective method. If RPO is 1 hour, then backup must over in 1 hour. RPO is used before an event occur. Like obviously if before an event is occurred, RPO is used. Now what about RTO? It is the maximum length of a time a computer system, network, or application is down after a failure. The failure is occurred, system failure is occurred. Now the time in which it will remain same. So supposedly it will remain in this state for 4 hours, then the 4 hours will be RTO. So if it is remained like this for 3 hours, like without recovery, it will, like, we have 3 hours of time or 4 hours time or like 2 hours of time or 1 hour of time to recover the system, then that period of time will be known as RTO. Supposedly if RTO is 30 minutes, then recovery should be covered in that time only. The shorter the RTO, the higher will be the cost of recovery. Talk about active passive and active strategies. So first of all, if you see this, so in active passive strategies, what happens that this is a production and it is connected to the network, and you can see there are two systems. So first is active, which is being used by the users right now, and the other one is passive, which is a standby in case anything goes wrong and this system goes down. And then for the recovery, obviously we have to go for the standby option. So after a disaster, we have to use this particular standby option, and this is how our active passive strategies work. Right now, here when it is on standby, it is not in working mode. All the instances and all the things are not being activated. So it will only get activated when our active or our first production system will not work. So afterwards we are going to make it active. So right now one is active, the other one is on standby mode. So this is active passive strategies, and we can see that there will be a lot of downtime in this particular recovery method, and uh, it will take more time. The downtime will be high, but the cost will be lesser. Now if we'll talk about active strategy, then you can see here in active strategy that both the regions, or you can say both the production systems, are active. Right now it is being used by the users, and uh, in case it goes down, then after a disaster we can easily get to see this other one. We can use this system, and in this case the downtime will be very less, or you can say zero only, but the expenses will be higher, like it will be more expensive than this one. So there are two strategies which are followed in disaster recovery. We will talk about the other strategies in the active passive and active. So under active passive strategies, there comes backup and restore, pilot light, and warm standby. So you can see in the active there is multi-site. So backup and restore, you can see here that this is the lower priority use cases, and the downtime for this is the highest. It goes for hours, and the cost is the least. And in the pilot lights, it take like tens of minutes. Like it is more. The downtime is lesser than backup and restore, but the expenses are more than the backup and restore. And likewise, warm standby, you can see that although the downtime is really less comparatively from the previous ones, but the expenses are really high, and this is business critical. This is used for certain businesses. And for the multi-site, in which active strategy is there, so the downtime for this is zero, but it is the costliest, like it is the most expensive one. So for the critical projects and where we want the downtime should be zero, there we use go multi-site methodology. And now here we can see through the graph also, like I've already explained it, but here you can see that in the backup and restore, you can see there is a production zone, here is a production zone, and likewise here is a standby system. So you can see that right now it is not active, and from the cross region backup only one side is getting, or the network, but this network will get active only when there will be some disaster, or when there is a like when there is the need of that backup system. Now in the standby, you can see, or the pilot light first, you can see that this zone is already active, and from the connection from the internet route 53 only the active ELV is getting the connection. And here you can see that this is inactive for production traffic. And but here not all the entire zone is inactive. Here auto scaling group and auto scaling group is already active, and from the Amazon Aurora there is asynchronous cross region replication which is happening, so it will not take a lot of time for the recovery. That is why only tens of minutes will take for the recovery period. And here we can see warm standby. So in warm standby you can see that although the network is only going in the active one, but in the inactive production traffic for the standby one everything is looking active, and there is an asynchronous cross region application also happening. But still the route 53 is blocked for the passive side. It is only the connected when the disaster happens, and it will take minimum time. Like see, everything is auto scaling group is also working, even the instances are also working for one AZ, and the other AZ the instances and everything will work later on when it will be manually activated or whatever IAC they want to follow. Now if we talk about active one, so multi-active, you can see that either the connection can go here also and here also, like whichever production zone they want to run or they want to use, they can use any production zone, so both the sites are active. So in this case we will get both the zones like in zero downtime. Supposedly if there is an issue in this AZ, so it will automatically get the backup from these AZs, but with the zero downtime.